Okay, so today what we're going to be doing is we're going to be talking about simultaneous equations. And when I say that, I mean basically solving two equations at the same time to obtain the value for two different variables. A little bit different to what we're normally used to. Okay, now these are the two equations that we're going to solve first up, but let's have a little bit of a delve into what this actually means. Okay, when we talk about the solution to simultaneous equations, solving these two for example at the same time, it's actually the point of intersection where they cross of the two curves. Okay, so that's graphically what it means, and I'll show you that very, very shortly, but we'll get into actually solving these two equations first. Okay, so first off, you might notice these two equations have both an x and a y in it. Normally when I give you an equation, what you're looking at is just one variable, like x plus 3 equals 5, or k minus 2 equals 7. It's just one variable that you're trying to find, not two, both x and y. Because we have two variables, we need two equations to solve them. Okay? Three main tools that we are going to be able to use to solve these. The first one will be graphically, which I'll show you shortly, which doesn't work in all cases because of the scales of your axes, okay? It can make it a little bit difficult. The one that will be in this video today, which we'll be focusing on, will be the elimination method, and the one that will be in the next video will be the substitution method. Okay, so let's get started on the elimination method. Our whole aim when we're trying to solve equations simultaneously is to remove one of the variables so we don't have to deal with it. Whether that is x, so we only have an equation in terms of y, or whether it's y, so we only have an equation in terms of x. Now, with the elimination method, okay, we are going to eliminate one of the variables in these two equations, right? And I'll show you what I mean by that in just a moment, okay? First thing that I want you to do before you start any question is I want you to label both of your equations, 1 and 2. So equation 1 and equation 2. To decide which variable that you're going to try to eliminate, okay, you should be looking for variables that have the same coefficient out the front. Okay, so you'll notice here, x both have a coefficient of 1 in both equations. So just be careful with that, right? That is what we are looking for. You'll also notice that there is a 1 out the front of both y's. So we could also eliminate y's, but our target that we want to work with is going to be x. We are going to try to eliminate x. And to do that, and this will make a little bit of sense in a moment, what we are going to do is we are going to do equation 1, everything in equation 1, minus everything in equation 2. So 1 minus everything in equation 2. To do this, and you'll see what I mean by how we eliminate a variable by doing this, okay? If you work down your columns, x minus, remember we're minusing, so I might just put like a little bit of a minus there so we can see that. X minus x, okay, becomes 0. Now y minus y. So just be careful with that. Over here, if I do y minus y, two negatives, if we remember, becomes a positive. So this actually becomes y plus y. So just be careful with that. So y plus y we know is going to be 2y working down that column. Okay, and then 7 minus 5 is equal to 2. Okay, you'll notice here we now no longer have an x. We've eliminated the x, okay, our variable. So I'm just going to move this up so you can see where we're going. We also have an equation only in terms of y, and we can solve these. We've worked with these before. Okay, so to solve this we just need to divide both sides by 2, okay, and end up with y is equal to 2 divided by 2 is 1. But we're not finished yet. What we need to do now, okay, if we found a solution for y, we need to plug this back into one of our two equations, okay, so we can find a solution for x. So what I like to write is I say sub y equals 1 into, and you can pick whichever equation that you want to work with here, okay. I'm going to pick equation 1 just because it'll work nicely for me, okay. So you'll notice here, alright, if we're subbing it back into 1, alright, if we end up working with this, this becomes x, and wherever we see a y, we now replace it with a 1. So x plus 1 is now equal to 7. Okay? Now I'll just move this up so you can actually see properly what we're doing and where we're heading. Alright? So x plus 1 is equal to 7, looking like this. Again, a variable, the only variable in this equation is x, so we can solve this by minusing 1 from both sides. Okay, so we end up with x is equal to 7 minus 1, which is 6. So our solution to this simultaneous equation is x is equal to 6 and y is equal to 1. Okay, so x is equal to 6 and y is equal to 1. So what does this actually mean visually? Okay, what are we actually doing? What we're actually doing is this. You notice the red and the blue line, okay, are the two equations that we've drawn out here. Okay, and where they meet, you'll notice that they meet at x is equal to 6 along the x-axis and y is equal to 1. Okay, that is their point of intersection, and that is why we solve these guys simultaneously. Okay, so again, just re-highlighting, we tried to eliminate a variable, okay, to get it in terms of only one variable, that happened to be y, okay, and then we solved it and subbed that answer back in to gain our second answer. Okay, so why don't we have a bit of practice with a harder example? So again, with this one, we're still trying to find x and y. We're trying to solve these two equations simultaneously and to find the point of intersection where they meet. So let's have a little bit of a play. Just like last time, again, we're using the elimination method, but we should label our equations so we can be clear to whoever is reading this, whoever we're trying to communicate our working to, they can understand exactly what we've gone through. Okay? So I told you before, the variable that you want to pick, okay, to eliminate should have the same number, the same coefficient in front of them. Okay? You'll notice here, in front of the y's, we have a 3. Okay? So instead of eliminating x, we are going to make our target y. Okay? Now, last time we subtracted the equations. Okay? You'll notice that because these guys have different signs, okay, we need to add these two equations to disappear. If we subtract them, this would become minus 3y minus another 3y, which gives us 6y, and doesn't actually eliminate the variable like what we wanted. So, let's have a little bit of a look into this, okay? We are going to add the two equations together. Equation 1 plus equation 2. Okay? So, working down the columns, 2x plus 3x is 5x. 3y plus negative 3y cancels each other out and becomes 0. Okay? And then 0 plus 5 is still 5. Okay? If you didn't quite understand that, okay, you can add it another way. You could do 2 plus 1 instead, and then minus 3y plus another 3y brings it to 0. Okay? Had we subtracted the equations, and I'll just write this over here, had we done 1 minus 2, just looking at the y's, this would be 3y minus 3y. And like we said before, okay, these two negatives make a positive, making it add together, which doesn't actually eliminate the variable like we were hoping. Okay, so remember, we're trying to get it in terms of one variable in the equation so we can solve for it and then sub it back in. Okay, so we now have the equation 5x is equal to 5. All we have to do now is divide both sides by 5. Okay, and x is now equal to 5 divided by 5 is 1. Okay, so we found x. Okay, the next thing that we need to do is we need to find y by using our answer here. We've done all of this work, so now let's use this to find what our answer will be. Okay, so you can sub it back into any equation that you would like. I'm going to sub this back into, why don't we pick equation 2? So I'm going to say sub x equals 1 into equation 2. Okay, so that means wherever we see an x in this equation up here, we now replace it with a 1. So we have 3 times 1 minus 3y is equal to 5. Okay, so 3 minus 3y is equal to 5. I'm just going to bring this up so you can still see what we're doing. Okay, I need to subtract 3 from both sides, so minus 3 and minus 3. Okay, that will cancel there, leaving us with minus 3y is equal to 5 minus 3 is 2. Okay, and now I need to divide both sides by negative 3. Okay, cancelling, leaving us with y is equal to 2 over minus 3, or just negative 2 over 3. So our two solutions that we end up with, okay, are x equals 1 and y equals minus 2 over 3. Okay, again, graphically, what does this mean? This means, for our two lines, the purple and the green line, Okay, the point of intersection occurs here at x equals 1 and here at y equals negative 2 on 3. We need to be careful when using the visual method. As you can already see, it becomes quite difficult for us to use if our axis is not holding up to scratch. Okay, so just be careful with this. Our most exact answers are going to come from this, the algebraic method. But it is nice to be confirmed that we're roughly on the right track, and you can use this to check as you go. Okay, so why don't we start on a little bit of a harder example where we have to manipulate one of the equations. So for example 3 here, what we're going to be doing is the exact same process, except we need to do a little bit of work before we start eliminating our variables, okay? So again, label them 1 and 2. Now I told you before, you want to pick the variable that has the same coefficient out the front to try and eliminate it. You'll notice that there's a 1 out the front of this x, but a 2 out the front of here, okay? And there's a 2 out the front of this y, okay, but a negative 1 out the front of here. So we can't quite eliminate straight away. We need to do some work beforehand. So what I'm going to do is that you'll notice that I can multiply this x here by 2 to have a 2 out the front. But that means I have to multiply everything else in this equation by 2 as well. Okay, so I'm going to manipulate this first equation like so by multiplying by 2. So you can see what I'm going to do. So if I multiply this x by 2, I have to multiply everything else by 2 as well to keep it the same equation. Okay, so 2x plus 4y is now equal to, and 2 times 8 is 16. Now we have a new equation, so we can't let this one go unnamed, and we're going to name it equation 3. Okay, so that way we're being clear again with our working out. You'll notice we are trying to eliminate x here. We deliberately did that, okay, to manipulate this first equation here to have the same coefficient out the front of x. So let's work by eliminating x. Because these two have the same signs out the front, they both have a plus, what we are going to do is we are going to subtract the equations. Now you can subtract them in any order. You can do 2 minus 3 or 3 minus 2. What I'm going to do is I'm going to do 3 minus 2. No particular reason, just because I can. It also helps because you have some larger numbers in the lesser equation, but let's go for it. So 2x, we'll just put a bit of a red subtraction sign so you can see what we're going to do here. 2x minus 2x is going to be 0. That's exactly what we wanted, to eliminate that variable x. 4y minus minus y becomes plus y, so that becomes plus 5y, okay? And now we have 16 minus 9, which is equal to 7. 16 minus 9 is equal to 7. So we have 5y is equal to 7, okay? Dividing both sides by 5, we end up with y is equal to 7 over 5. Now, all of the other numbers we've worked with have been whole numbers. So, nothing different, but this time we're just going to have to play around with a little bit of fractions, which means there's more chance for error. Okay? So we're going to sub our solution in here, because we still need to find x. Sub y equals 7 over 5 into, and we're going to pick which equation that we're going to work with. Personally, I'm looking at this between equation 1 and equation 2, so you'll just see here, I've just said sub y equals 7 over 5 into, I'm going to work with subbing this into equation 1. Okay, and you'll see why. Okay, it is a little bit easier to work with because we're trying to find x and there's nothing attached to it. So that's why. It's just less work for me. So sub y equals 7 over 5 into 1. Okay, so that means wherever we see a y, okay, we're going to replace it with 7 over 5. Alright, so now using our first equation we have x plus 2 times 7 over 5, okay, is equal to 8. And you can see that based off our first equation. Wherever we've set a y, we've just replaced it with a 7 over 5. Alright, now what we need to do is we need to do a little bit of tidying up, okay? 2 times 7 over 5 simply becomes x plus 14 over 5. And you can use your calculator for that if you would like. Okay, we need to minus 14 on 5 from both sides, okay, to get the x by itself. Okay, minus 14 on 5 from both sides. And using a calculator, you come up with the answer of 8 minus 14 on 5 is actually equal to 26 on 5 after you've had a little bit of a play around. If you want to work through the fractions, then that's okay too. So your two solutions for this are x equals 26 on 5 and y is equal to 7 on 5. Okay, there are your two solutions for this simultaneous equation. Again, what does that mean visually? It just means here, the point of intersection of the two lines are x is equal to 26 on 5 and y is equal to 7 over 5. Okay? So let's try one more example, which is probably a little bit harder than this one, okay, with just one extra step. It's not actually any harder to understand, okay? So let's have a go at it. Okay, so for our fourth and final example, okay, we are going to try and pick a variable to eliminate, but we're just going to follow a little bit of a different process, similar to what we did before, except this time we're going to have to manipulate both equations, okay? So, like always, label our first equation to begin with, equation 1 and equation 2. Okay, so what we're going to do here is there's no way for me, say we're trying to eliminate x, there's no way for me to multiply 3 by anything easily, like a whole number, to get it to equal to 2, and vice versa. And the same for 4, there's no way that I can multiply 4 by anything easily, without using fractions or something, to get it to be equal to 3. So we have to manipulate both equations, okay, to equal the lowest common multiple, okay? And the easiest way of doing that is picking a variable that we want to eliminate. Let's just say I'm going to go for x to begin with for the moment, okay? Right, let's just say I'm trying to do that. If I multiply this 3 by 2, which is the coefficient of the second one, we get 6. And if I multiply this 2 by 3, we also get 6. And that means we're going to have the same coefficient going on here, okay? Which is what we want so we can eliminate x. So firstly, we're going to bring this down here, okay, and we're going to multiply the first one by 2. Okay, so the first equation, everything is multiplied by 2. So that becomes 6x plus 8y is equal to 20. Okay? Then, okay, we want to end up with the 6 in front of this x, so what we have to now multiply by, okay, we'll write that down here, so we're going to multiply it by 3, which is the coefficient of the other equation. So now we end up with 6x plus 9y is equal to 7 times 3 is 21. And we label these new equations. We have equation 3 and equation 4. Now, we want to eliminate x. They both have a plus out the front of the x's, okay? So we're going to subtract the equations. It's up to you in what order you want to do this, okay? You could do 3 minus 4. However, what I would suggest doing is looking at which ones are going to give you positive numbers so you're not working with negatives, okay? So, let's go through it. I'm going to do looking at this one, because it has larger numbers in the second equation, so I'm going to have a positive answer, okay, I am going to do 4 minus 3, okay, so 4 minus 3, okay, so then 4 minus 3, well this is 6 minus 6x, so we end up with 0, alright, 9y minus 8y is plus 1y, or just y, as we write it in algebra, and then 21 minus 20 is just 1. So we have y is equal to 1. You'll notice the extra step that we had to take was just generating an extra equation. It's not actually harder in terms of the actual elimination method to find the variable. Okay, now we have y is equal to 1. We need to sub this back into one of our equations. Technically, we could sub it into 3 and 4. We would get the same answer. However, we as people are often prone to making mistakes. So I would avoid substituting it into 3 and 4, okay, and only substitute your answers back into one of your original equations, okay? Just be careful with that. So what I'm going to do, just for something different, is I'm going to sub it into equation 2, okay? There's no reason why I can't sub it into equation 1. It's just going to be equation 2. So we have 2x, okay, and I should write what I'm doing first. So sub y equals 1 into equation 2. So substitute y into equation 2. We have 2x plus 3. Wherever we see a y, we're now replacing it with a 1 is equal to 7. 2x plus 3 times 1 is 3 is equal to 7. And now it's just a basic straight equation. So I'll move this up so you can see what we're doing. Okay, minusing 3 from both sides to keep everything balanced. Okay, we now have that cancelling. 2x is equal to 7 minus 3 is 4. Dividing both sides by 2. Okay, we have x is equal to 4 divided by 2, which is just 2. Okay, so our solution to this equation, okay, is x is equal to 2 and y is equal to 1. Alright, now again, for the final time, just making sure that we understand it, graphically, this represents the point of intersection on the Cartesian plane of these two lines, okay, of x is equal to 2 and y is equal to 1, okay? So, sometimes we have to modify the equation, particularly when we can't generate one of the coefficients by multiplying only one of them into the other, okay, which happened in this case, alright? Sometimes we won't have to, okay? This is a bit of a varied experience for you, so you can see the different types of simultaneous equations that you can come into contact with. Okay? I hope that helped.